So we have this chapter, human eye and colorful world. So before starting this chapter, just we have a simple question. How we are able to see the colorful world around us? So this is only due to the human eye. When the light reflected from the object enters into our eye, and when the final image is formed at the retina of the human eye, we are able to see any object around us. So let's see the basic structure of human eye. So the shape of the human eye is a spherical in shape. Generally the shape of the human eye is a spherical. So this is your spherical part. Human eye is spherical. The front part or the front curved part of the human eye, that is known as cornea. So this part is basically representing the cornea of human eye, through which the light will enter into the human eye. We have one layer surrounding this human eye, that is of the membrane layer. This layer is known as a sclera. This layer is basically a sclera. It is covering the human eye. We can take this cover. This cover is known as a sclera. The outer layer of human eye, it is a membrane, that is known as a sclera. And we have one iris. This part of the human eye, it is representing the iris. It is acting as the window through the human eye. It will control the amount of light entering into the human eye. Now next is the central hole. This is known as the central hole. This central hole, it is known as pupil. And this part, it is representing the iris. And we have one lens, that is known as crystalline lens. The lens is basically a convex lens. This is your convex lens. And this convex lens is supported with the help of the one muscle, that is known as ciliary muscle. This muscle is basically your ciliary muscle. This is representing your ciliary muscle. This is your ciliary muscle, and this is your lens. The lens is known as crystalline lens. It is a convex lens. The most sensitive part of the human eye, that is known as retina. This is the retina. This point is known as retina. It is the most sensitive part of the human eye. The final image will be formed at the retina, and the image formed at the retina, it is transferred or it is converted into electrical signal, and the signal is transferred via optic nerve to the brain. So here is one optic nerve. This is the nerve through which the image formed at the retina, that will be converted into electrical pulses, and they will be transferred to the brain for the recognition. So this is the basic part of the human eye. Now we will see in detail. This part is known as front part of the human eye, and this part it is known as the interior part of the human eye. The front part, it is covered with jelly type substance, that is known as aqueous humor. Aqueous humor. And this interior part of the human eye, it is also covered with jelly type of liquid type substance, that is known as vitreous humor. So these are the different components of the human eye. Let's again recall the basic parts. First part is the cornea. This is the outer most curved part of the human eye, through which the light will enter into the human eye, is known as cornea. The next part is the iris. This is known as iris. Iris is also known as the window. The amount of light entering through the lens, it will be controlled by the iris. In case of the dim light, this iris will contract in order to open the sides of this pupil, so more light can enter. If more light can enter, then object will be visible. In case of bright light, this iris will expand. When this iris will expand, the size of this pupil, central hole, this will reduce, and that will allow the less light to enter into the human eye, or that is the lens, and the object will be clearly visible. And next part is your retina. Retina is known as the most sensitive part of the human eye, and retina is containing two types of cells. One we have rod cells, other is known as cone cells. So the function of rod cells and cone cells is, rod cells respond to the intensity of the light and cone cells respond to the color of the light. So rod cells will respond to the intensity of light, means how much amount of light energy it is entering through the human eye, that will be responded by the rod cells at the retina, and cone cells will recognize the color of the object, that cone cells respond to the color of the human light. So this is the basic function. Now we will see what are the different components, just we will recall. So what we have seen, different parts of the human eye, we have seen the following parts of the human eye. The first part is your cornea, the second part is your iris, third part is your pupil, fourth part is your ciliary muscles, and fifth part is your lens, sixth part is your retina, seventh part is your optic nerve, next is your aqueous humor, next is your vitreous humor, and last is your sclera. So these are the different components of the human eye that we see in the physics. First is the cornea. Cornea is the outermost part of the human eye through which the light will enter. Iris is known as the window of the human eye, means the amount of light entering to the human eye that will be controlled by the iris. This is known as iris. Here you can see the position of the iris. This part of the human eye is known as iris. It will expand and contract in order to control the amount of light entering through the human eye. So that is the function of the iris in the human eye. And iris will also determine the color of the human eye. Depending upon the color of the iris, that will be the color of the human eye. Next is the pupil. The size, this hole through which the light is entering, that is known as pupil. And next part is the ciliary muscles. Ciliary muscles is helping to adjust the focal length for this convex lens, this crystalline lens. And next we will study in detail about the ciliary muscles, of the function of the ciliary muscles. Then lens, this lens is known as crystalline lens. It is basically a convex lens. It will form real inverted image at the retina. Next we have optic nerve. This part it is known as optic nerve. The image which is formed at the retina, it will be converted into optical signal, and that optical signal it is transferred to the brain via optic nerve. Next we have aqueous humor. So aqueous humor, this front part of the human eye, it is covered with jelly type substance or liquid type substance, that is known as aqueous humor. So aqueous humor will just protect the human eye from the dust particles. When the dust particle will hit the human eye, so there will be injury. So if jelly type of the substance will be there, if front part of the human eye it is covered with the jelly type of the substance, so dust particles or other particles that is absorbed, they are not allowed to enter or hit the front part of the human eye. This is known as the interior part of the human eye. Interior part is also covered with this jelly type substance we have already seen, that is known as vitreous humor. So vitreous humor will help in maintaining the pressure of this human eye. It will always maintain the pressure equal to the atmospheric pressure. So it will help to or it will helping in adjusting the pressure of the human eye, so that the human eye does not collapse when the atmospheric pressure is more or less. Whenever atmospheric pressure is increasing or decreasing, the pressure of the human eye it is adjusted with the help of the vitreous humor, liquid. So this is the basic parts of the human eye, just we have seen. Hopefully you have understood this different components or different parts of the human eye and their function. So this is a very small topic of class 10th physics, and you can easily understood from these diagrams what are the different functions of these parts of the human eye, and working also we have seen. Now we will start with one term From the lens formula, we have one term. We will see one definition here, that is known as power of accommodation. Power of accommodation. We know about a general lens formula. Lens formula we have, suppose we have a convex lens. Once you will choose a convex lens and medium is fixed, its focal length will be fixed. Suppose focal length of this lens is f. Now, once you are changing the position of the object, suppose object is placed here, somewhere here, then image is formed here. Suppose image is here. Once you will change the position of the object, suppose now position of the object is changed. Suppose it is O dash, then the position of the image will also change. Suppose now new position of the image is suppose I dash. So this is the case in case of convex lens. The formula is 1 by V minus 1 by U is equal to 1 by F. This is giving the relationship between U for object distance, V for image distance, and F is the focal length of the lens. So relationship between object distance, image distance and focal length of a lens, it is known as lens formula. So once you are changing the object distance, image distance will also change. Suppose we are changing this equation, 1 by V is equal to 1 by U is equal to 1 by F. 1 by V is equal to 1 by U plus 1 by F. Now in this equation, focal length is generally constant. So once you are changing the position of object distance if it is changed, then the image distance will also change. So this is the case in case of a general lens, but this case is not applicable in case of human eye. In case of human eye, you can easily see, suppose this is your human eye, this is the position of the lens. Suppose this is your lens, this is the curved part, and this is the lens, and this is your retina. Suppose final image is formed at the retina and this is the position of the lens. So this image distance is approximately equal to 2.5 centimeter, that is equal to the diameter of this human eye. So whatever is the position of the object, if object is placed here, suppose object is placed here, this is O, this is your O1, suppose object is placed here, O2 dash. So whatever is the position of the object, image is always formed at the retina. So how is it possible in case of human eye? This is only possible due to the fact that, look, we are changing if we have the formula 1 by V minus 1 by U is equal to 1 by F, focal length, just I have explained, focal length is generally constant. If the medium is fixed, once you will choose the lens, focal length will be a constant. Once you are changing the object distance, image distance must also change. But in case of human eye, the distance between the lens and the retina, it is always fixed, that is equal to 2.5 centimeter. So image distance is not changing in case of human eye, only we are changing the object distance. If object distance is changing, then right of the equation, in order to make this equation correct, if U is changing, so towards the right of this equation, focal length must also change. So focal length of this human eye, or focal length of the crystalline lens of the human eye is always changing with the help of these ciliary muscles. Ciliary muscles helps in adjusting the focal length of this human eye, whatever is the position of the object, the image is always formed at the retina. This is only possible that we are changing the focal length of this crystalline lens. And the focal length of this crystalline lens is adjusted with the help of the ciliary muscles. So this is the function of the ciliary muscles. Now we will see the power of accommodation. What is the range of vision of the human eye? We will see the range of the vision of the human eye is basically from 25 centimeter to the infinity. The near point is infinity. The next term is power of accommodation. So just we have seen in case of human eye, the focal length is changing. The self-adjusting behavior of the human eye to change its focal length. This is the crystalline lens of the human eye, and suppose this is your human eye and this is your the cornea through which the light will enter. Light is coming from the object, it is entering to the crystalline lens, and after refraction the image is forming at the retina. This is the image. So the image is always formed at the retina with the help of changing focal length. this is V. V is always fixed, but you can change in case of the human eye. The object can be placed at 25 centimeter. This is known as the near point. The minimum distance at which the object must be placed or object is placed so that it can be seen clearly by the human eye, that is known as least distance of distinct vision. For the normal human eye, adult eye, for an adult person normal vision is least distance of distinct vision is 25 centimeter, and if the object is placed at the infinity also, then that can be visible. So near point is 25 centimeter and the far point is infinity. Whatever object is placed in between infinity and 25 centimeter from the human eye, this is the range within which if the object is placed, the object can be seen clearly by a human eye, normal human eye. So now we can calculate what will be the power. So we have the general formula for the power of a lens. Since this lens is a convex lens, so power P will be equal to 1 by F. Reciprocal of the focal length, and focal length must be measured in meter. Let's see what will be the power of this crystalline lens of the human eye when we are placing the object at least distance of distinct vision, that is at the near point, and when the object is placed at the far point. So first I am calculating the power at near point. So for near point, what is the position of the object? The object distance U will be equal to 25 centimeter and it is placed towards the left, so I am taking by sign convention 25 centimeter negative sign. Where is the position of image? Image is formed at the retina. This distance is basically equal to 2.5 centimeter. So image distance towards the right I can take positive 2.5 centimeter. Then now by lens formula 1 by V minus 1 by U is equal to 1 by F. Focal length we can measure. Put the value of V, 1 by 2.5 minus 1 by U. U is minus 25 is equal to 1 by F. So when we will solve it, we will get F is equal to 40 centimeter. This is the focal length. Or we can calculate minus minus plus 10 by 25. So no, this will not be the value. We can just calculate. We can easily calculate 1 by 2.5. So we can write down 10 by 25 minus minus plus 1 by 25 is equal to 1 by F. 25 LCM, 25 10 plus 1 11 by 25 is equal to 1 by F. So F will be equal to 25 by 11 centimeter. Now we can convert into meter. When you will convert into meter, divided by 100. So 25 by 11 divided by 100. 25 into 400, that is 1 by 44 meter. Now power we can easily measure. Power is equal to 1 by F and focal length must be in meter. So power P will be equal to focal length in meter we have calculated. It is equal to 1 upon 44. So P will be equal to plus 44D. So this is the power of the lens. Human eye, crystalline lens of the human eye when the object is placed at the near point. Same thing we can calculate, the power we can calculate when the object is placed at the far point. So what is the far point? The far point just I have explained. The far point in case of the human eye, it is infinity. So object is placed at the infinity, so object distance will be infinite. And image is always formed at the retina for the normalized 2.5 centimeter. Again we can calculate the focal length. In this case, by using the formula 1 by V minus 1 by U is equal to 1 by F. This formula, so 1 by V is equal to 2.5 minus U is equal to infinity. When we are dividing any term with the infinity, that is equal to 0. So it will be equal to 10 by 25 is equal to 1 by F. So F will be equal to 25 by 10. In centimeter, when you will convert into meter, F will be equal to 25 by 10 divided by 100. So F will be equal to 25 into 400, 1 by 40 meter. So power in this case, it will be equal to 1 by reciprocal of the focal length must be in meter. So P will be equal to 1 by 1 upon 40. So it will be equal to plus 40D. So this is the power when object is placed at the far point, and the power we have calculated when the object is placed at the near point. So plus 44D and plus 4D. The eye of the crystalline lens of the human eye will adjust the power in between these two values. So when the object is placed at the infinity, the power is plus 40D, and when the object is placed at the least distance of distinct vision denoted by D, the power of the lens is plus 44D. D is the diopter. Diopter is the unit of the power, and whenever the object is placed between in this position infinity and least distance, The power we can adjust, power will be adjusted between 40 plus 40D and plus 44D. So power of accommodation we can calculate, power of accommodation. So power of accommodation of human eye, it will be in between, you know, these two values. So we can subtract 44D minus 40D, whatever value we are getting, plus 4D we are getting. So plus 4D is the power of accommodation of the human eye. So hopefully in this topic we have seen some of the terms, like we are starting from the, just recapping this first part. First we have seen the human eye, the basic structure of the human eye in the colorful world. In this topic we have seen the different components of the human eye and their working, and we have seen these different components: cornea, iris, pupil, ciliary muscles, lens, retina, optic nerve, aqueous humor, vitreous humor, sclera. And then we have seen the lens formula also, because lens, crystalline lens in case of the human eye is a convex lens, so we can apply the lens formula anywhere. Then we have seen the general difference between a lens and the lens in case of human eye. In the next topic we have seen the power of accommodation. This is the power of accommodation I have defined. Just I have explained, whatever is the position of the object, or irrespective of the position of the object, the image is always formed at the retina. This is possible only due to the fact that the focal length of this lens is changing, and the focal length of this lens is changing. The change in focal length, it is adjusted with the help of the ciliary muscles. And how it is changing, as just I have explained, two different points I have explained, near point and far point. And we have calculated the power of the lens in these two cases. Just we have seen, in case of near point the power is plus 44D, in case of far point the power is plus 40D. So basically lens is adjusting the power in between these two values. So power of accommodation is plus 4D. Hopefully you have understood some of the parts of the human eye and the power of accommodation. Thank you.